Plate tectonics is a fundamental theory in geology that describes how the Earth's crust moves and shapes our planet. This theory proposes that the Earth's outer layer is composed of large plates that move relative to each other over the underlying mantle. The concept of plate tectonics was first introduced in the 1960s and has since been widely accepted by the scientific community. The significance of plate tectonics lies in its ability to explain a range of geological phenomena. By understanding how the Earth's plates move and interact, we can gain insight into the formation of mountain ranges, the creation of volcanic islands, the occurrence of earthquakes, and the evolution of the Earth's continents. In summary, plate tectonics is an essential theory in the field of geology that provides us with a framework for understanding the movement and behavior of the Earth's crust. Through its application, we can gain a better understanding of the processes that have shaped our planet and continue to shape it today. In plate tectonics theory, there are three main types of tectonic boundaries: divergent, convergent, and transform boundaries. At divergent boundaries, plates move away from each other, resulting in the creation of new crust. This process can occur on land, such as the East African Rift Valley, or under the ocean, such as the Mid-Atlantic Ridge. Divergent boundaries can also result in volcanic activity, as magma rises to the surface and cools to form new crust. Convergent boundaries occur when two plates move towards each other. The collision can result in one plate being subducted under the other, forming a subduction zone, or the plates can crumple and push up mountains. The collision of continental plates can also create large plateaus. Transform boundaries occur when two plates slide past each other horizontally. This can result in earthquakes, as the plates grind against each other. The San Andreas Fault in California is a well-known example of a transform boundary. Understanding the types of tectonic boundaries is important in predicting geological events such as earthquakes, volcanic eruptions, and mountain building. Plate tectonics is responsible for shaping many of the geological features we see on Earth today. The movement of tectonic plates can create mountain ranges, rift valleys, volcanic islands, and earthquakes. Let's take a closer look at these geological features. Mountain ranges, such as the Himalayas, are formed at convergent boundaries, where two plates are colliding and pushing against each other, causing the land to uplift and fold. Rift valleys, like the Great Rift Valley in Africa, are formed at divergent boundaries, where two plates are moving away from each other, causing the land to stretch and thin. This can create a depression or valley in the Earth's crust. Volcanic islands, such as Hawaii, are formed at hot spots or divergent boundaries, where magma rises to the surface and creates a volcanic eruption. Over time, repeated eruptions can create an island chain. Finally, earthquakes are caused by the movement of tectonic plates. When two plates rub against each other, they can get stuck and build up pressure. When this pressure is released, it causes an earthquake. The location and strength of an earthquake can provide clues about the tectonic plate boundaries in the area. So, as you can see, plate tectonics is responsible for many of the geological features we see on Earth. Understanding these features and the forces that create them is an important part of geology and our understanding of the planet we live on. Plate tectonics theory has revolutionized the way we think about the Earth's history. By understanding the movement of the plates, we can infer what the Earth's surface may have looked like millions of years ago and how it may change in the future. One of the most significant contributions of plate tectonics theory to our understanding of the Earth's history is the concept of continental drift. This theory proposes that the Earth's continents were once a single supercontinent called Pangaea, which began to break apart about 200 million years ago. The idea of continental drift was initially met with skepticism, but with the discovery of mid-ocean ridges, it became clear that the Earth's crust was in constant motion. In addition to the concept of continental drift, plate tectonics theory also helps us understand the formation of supercontinents. Every few hundred million years, the Earth's continents come together to form a supercontinent, which then breaks apart again. This cycle of supercontinent formation and breakup is a key aspect of plate tectonics theory and has shaped the Earth's landscape for billions of years. Overall, plate tectonics theory has had a profound impact on our understanding of the Earth's history and geologic processes. By studying the movement of the plates and the geological features they create, we can better understand the natural forces that shape our planet. Plate tectonics theory has many practical applications, and in this section, I'll be discussing some of them. One of the most important applications of plate tectonics theory is in understanding natural disasters. By studying the movement of tectonic plates, we can predict where earthquakes and volcanic eruptions are likely to occur. This knowledge can help us to prepare for these events and minimize their impact on human populations. For example, we can design buildings to withstand earthquakes or create evacuation plans for areas that are at risk of volcanic eruptions. Another important application of plate tectonics theory is in the formation of natural resources. The movement of tectonic plates can cause the formation of mineral deposits, oil and gas reservoirs, and other valuable resources. By understanding the processes that create these resources, we can more effectively locate and extract them, which is critical for industries such as mining and energy. Finally, plate tectonics theory can also help us predict geological events. By studying the movement of tectonic plates, we can anticipate changes in the Earth's crust and predict when and where geological events such as earthquakes and volcanic eruptions are likely to occur. In summary, plate tectonics theory is a vital tool for understanding the Earth's geological processes and has important applications in predicting natural disasters, forming natural resources, and predicting geological events. Plate boundaries play a significant role in shaping our planet's geology and affecting human activity. The first way plate boundaries impact humans is through their impact on human settlements. Areas near plate boundaries are more susceptible to earthquakes, tsunamis, and volcanic eruptions. As a result, people living in these areas need to be prepared for natural disasters and take necessary precautions to minimize the risks. The second way plate tectonics affect human activity is through the formation of natural resources. Plate movements can cause the accumulation of minerals and hydrocarbons, which are used to produce energy, fuel, and raw materials for various industries. For example, oil and gas deposits are often found in areas where tectonic plates have converged or diverged, leading to the formation of sedimentary basins that trap hydrocarbons over millions of years. Finally, humans can also influence plate tectonics through human-induced earthquakes. These earthquakes are caused by human activities such as oil and gas extraction, geothermal energy production, and underground nuclear testing. Although these activities do not directly affect the movement of tectonic plates, they can change the stress levels in the Earth's crust, leading to seismic activity. Overall, understanding plate tectonics is crucial in predicting natural disasters, exploring and exploiting natural resources, and minimizing the negative impacts of human activity on the environment. Plate tectonics is a fascinating topic that helps us understand the geological processes that shape our planet. In this video, we have explored the definition and history of plate tectonics, the different types of tectonic boundaries, the geological features resulting from plate movements, plate tectonics and the Earth's history, and the various applications of plate tectonics theory. We have seen how the theory of plate tectonics has revolutionized our understanding of the Earth's geology and helped us predict geological events and natural disasters. The formation of mountain ranges, rift valleys, volcanoes, and earthquakes can all be explained by plate tectonics. Moreover, the theory of plate tectonics has provided us with insights into the Earth's history and the evolution of life on our planet. It has also helped us understand how natural resources, such as oil and gas, are formed and where they can be found. In conclusion, plate tectonics is a crucial concept in geology, and its importance cannot be overstated. By studying plate tectonics, we can better understand our planet and its history, predict geological events, and make informed decisions about natural resources and disaster preparedness.